Okay, I want to look at this this problem on word problems on differential equations. Slightly harder problem. I should mention, I think this is from the 1984 exam, and this is question 10, and it's the B part. Okay, would have been considered quite challenging, but you know, we're going to start by translating from English into our language of mathematics, languages of algebra and calculus. And then we'll think about where we're going to go from there. So a car freewheeling on a straight road experiences a retardation which is proportional to the square of its speed. Its speed is reduced from 20 to 10 in a distance of 100 meters. Calculate the time taken to travel the 100 meters. Okay, so let's take the first sentence. It experiences a retardation, that's a slowing down, which is proportional to the square of its speed. And two variables are said to be proportional if one is a constant multiple of the other. So the acceleration must be a constant multiple of the square of its speed. I'm going to use v for velocity. The other thing is its speed here is positive. Its velocity, positive velocity, well, that means a slowing down would mean a negative acceleration. So that's going to be our equation. That's everything is going to come from this. A is equal to negative k times v squared. Also, if we look at the conditions on the question that are given in the second sentence, it said its speed is reduced from 20 to 10 in a distance of 100. So the first thing there, the velocity is 20 and the displacement is 0 when the time is 0. You know, it starts at 20 at the start of this question. It may have been in motion before that, but the start of our question is when it's at 20 meters per second. So no time has passed, which means no displacement can have occurred. No change in time, no change in position. V is equal to 20 at that moment. The other thing it tells me is that V is equal to 10 when S is equal to 100. When it's traveled a distance of 100 meters, when there's been a 100 meter change in position. What are we asked to find? We're asked to find the time taken to travel the 100 meters. So find t when S is equal to 100. And of course we know that when S is equal to 100, V is equal to 10. The other thing we know is, you know, if we think about acceleration, we have two substitutions that we can use. Now we've looked at both of these in detail in previous lessons, so if you're unsure about these substitutions, you know, have a go over the previous lessons, make sure you know them. We're trying to find the time when S is 100, when V is 0. So I'm trying to find the time when S is 100, when V is 0. So one thing I might do is come up with an expression between the time and the velocity. So maybe I might take this original equation and use the substitution dv dt is equal to negative k times v squared. Now, bearing in mind that k is a constant here, that's a fairly straight first order separable differential equation. And I'm going to separate and integrate. Dividing on both sides by v squared, that's v to the negative 2, 1 over v squared, v to the negative 2, dv. Multiplying on both sides by dt, we get negative k times dt. And I'm going to integrate. Negative k, remember, is a constant. So, antiderivative v to the power of negative 2, increase the exponent by 1, divide by the new exponent. That's going to be negative k, whatever k is. We don't know what k is, times t plus c. So we don't really know what k is yet. So we can see if we can find something. Maybe we'll find the constant of integration and figure something out. So it says that v to the power of negative 1 is 1 over v divided by negative 1. That's negative 1 over v is equal to negative whatever k is. Again, I emphasize we don't know what that is yet. At some stage we're going to have to find it to solve the question. But, you know, we do know that negative 1 over v is equal to negative kt plus c. Okay? So I'm going to go back on my initial conditions and see if there's something that'll help me to find the constant of integration. We know that v is equal to 20 when t is equal to 0. So, but v is equal to 20 when t is equal to 0. So therefore, negative 1 over 20 is equal to, well, k times 0 is just 0 plus c. So I can come up with my particular solution. And again, let me just remind you that that's in terms of t. Therefore, negative 1 over v is going to equal to negative kt minus 1 over 20. Solving for kt, well, k times t is going to be adding 1 over v to both sides. 1 over v minus 1 over 20. So that's going to be, ultimately we're trying to find the time. So the time, dividing on both sides by k, the time is going to be 1 over v minus 1 over 20, all divided by k. So if I know what k is, I can now solve for t. So that's important. I have an expression for t, but my expression depends on k. I'm trying to find t. Remember what we're trying to find? I'm trying to find t when v is equal to 10, actually. So actually, when v is equal to 10, if we look at that, when v is equal to 10, the time is going to equal to 1 over 10 minus 1 over 20 all over k. 1/10 is 2/20. 2/20 minus 1/20. That's just 1/20. Dividing 1/20 by k will give me 1 over 20k. So if I can figure out what k is, I can say exactly what the time is. So the time taken for this object to reach 10 kilometers per hour is going to be 1 over 20k. So our job now is to find k. Okay, so we've found an expression for time, but it's in terms of k. How will we find k? And what I'm going to do to find k is I'm going to go right back to my original equation. My original equation said a is equal to negative k times v squared. And we had initial conditions. I'm going to scroll back up just to look at those again. Lots of information in my initial conditions connecting v and s. V and s. So if we get some equations connecting v and s, v in terms of s or s in terms of v, well then we can kind of maybe work out what k is from there. So in this second part of the question, this is ultimately why your textbook is saying it's a more difficult question, is because you're actually going to end up using both of our substitutions here for a. So the substitution I'm going to use now is v dv ds. Okay, it's a separable first order differential equation. Divide on both sides by v squared. Again, 1 over v on the left. Remember, v divided by v squared, just 1 over v. Multiply on both sides by ds. And we get 1 over v dv is negative k times ds. I'm going to take an antiderivative on both sides. The antiderivative of 1 over v, well, that's the natural log of the absolute value of v, is equal to negative k times s plus c. Okay, the antiderivative of 1 with respect to s is just s. Why no absolute value brackets in here? If you go right back up to the question, speed is always positive here. It's going from 20 to 10. Absolute value of positive things are always just the same thing. The absolute value of 20 is 20. So I'm ignoring my absolute value brackets here. So that's my general solution. Again, it's in terms of k. So there's going to be 2 steps from now. First, I'm going to find c, and then I'm going to find k. And to do each of those things, I'm going to have to look at the conditions in the question. And I think we said that v was equal to 20 when s was equal to 0. Let me scroll back up just to double check that. Yeah, so v is equal to 20 when s is 0. I'm going to use that. And also v is 10 when s is 100. I'll probably use that as well. So this is going to help me find the constant of integration. So the natural log of 20 is equal to negative k times 0 plus c. So c is the natural log of 20. So my particular solution here is the natural log of v is equal to negative k times s plus the natural log of 20. Okay. Remember, I'm looking for k, so I'm going to actually make ks the subject of this equation at this point here. Adding ks to both sides. Adding ks to both sides will give me ks on the left. And subtracting the natural log of v from both sides, that's going to be natural log of 20 minus the natural log of v, which, if you know your rules of logarithms, that's going to be 20 over v. So we have an expression for ks in terms of v. The second condition the question gave me, it said, but v was equal to 10 when s was equal to 100. I'm going to scroll up the page and just double check that I have that right. So v is equal to 10 when s is equal to 100. Scroll back down. V is equal to 10 when s is equal to 100. So I can just substitute that stuff in there. So we're going to get k times s. Well, that's 100k is equal to the natural log of 20 over v, which would be 20 over 10 in this case, which is the natural log of 2. So what I'm going to find here, dividing on both sides by 100, is k is going to be equal to the natural log of 2 over 100. So we have an expression for k. That's really everything we need to know, because what have we done? We've done two things. First, we found an expression for t, the time in terms of k, and now we've found an actual value for k. So we said, and t is equal to 1 over, we said it's 1 over 20k, which is going to be equal to 1 over 20 times the natural log of 2 over 100. Okay, and that's pretty simple to work out. You know, 1 over, that's going to be 1 over the natural log of 2 over 5. Okay, 20 times the natural log of 2 over 100. 20 over 100 is 1/5. And then dividing 1 over any fraction is just the reciprocal of that fraction. That's going to be the natural log of 2. So my final answer is the time is equal to 5 over the natural log of 2. Just double check, my units were meters per second, I think. So my time is going to be in seconds. And your calculator, if you plug that in, will tell you some kind of decimal approximation for that. Let me do that here while I have my calculator beside me. 5 divided by the natural log of 2. That's saying about 7.2 seconds. But if it was up to me, I would leave it like this, without the approximation. That's exactly what it is. 5 over natural log of 2. So, slightly more complicated example, but only because we're using the both substitutions. Remember, what are we trying to find? Think about what we're trying to find. We're trying to find a connection between t and s, or t and v. So I used dv dt to come up with an equation that linked t and v. And I was able to work that and find that t is always equal to 1 over v minus 1 over 20 over k. And then we were trying to find specifically the time when v was equal to 10. So I just substitute 10 in there. So my time I know is 1 over 20, whatever k is. I don't know what that is yet. To find k, I use my v dv ds substitution. because there's lots of information in the conditions, given conditions, that connects V and S. So this is going to help me find what K is. Once I found what K is, well, then I can substitute it back into my time expression that I've already found, and just a bit of simple algebra there to work out the time. So a little bit long-winded, but really nothing that you shouldn't be able for at this stage. So have a look at some of these questions, more difficult questions in 12I in your textbook, and please, on the new conversations thread, let me know if there's anything you want me to look at.